This video is to help you go through your Chapter 5 task and make corrections. So make sure you're looking at your chapter test as you go through each answer and recording on your cover sheet what you missed and why. This will help you know what to study for your retake, which is going to be in class on Friday, December 18th. For the first question, you were asked to complete these sentences. So when two equations have the same slope, the lines that they represent are parallel. When you solve an inequality, you need to change the direction of the inequality's symbol when you multiply or divide by a negative number. If a system of linear equations has an infinite number of solutions, then the graphs of the equations are on top of each other. Or you might have said that they are the same equation. Either of those would be fine. For problem 2, you needed to set up a system of equations. So first you were asked to define your variables. So for example, you might have done x equals the trumpet rentals and y equals the drum rentals. Then my system of equations, I know that trumpets are $12 a month, so 12x plus drums are 8 per month, so 8y equals $144. And I also know that there's 15 total members of the band who rent an instrument, so x plus y is going to equal 15. So now I'm going to go ahead and rewrite this equation so that I can solve for y. So in this case, y equals 15 minus x, so that now I can substitute into the other equation. So I'll have 12x plus 8 times 15 minus x equals 144. And 12x plus 8 times 15 gives me 120, and 8 times negative x gives me minus 8x equals 144. Now I can combine like terms. So I'm going to subtract 120 from each side, and I'm going to combine my 12x and my 8x. So I've got 4x equals 24, and now I'll divide by 4, and I get that x equals 6. So I'm thinking that x is 6, but I need to check both of my equations. So I know that if x is 6, I'm going to say 6 plus y equals 15. And if I subtract 6 from each side, I get that y equals 9. And I'm going to check my other equation as well. So 12 times 6 plus 8y equals 144. 12 times 6 would give me 72, plus 8y equals 144. Again, I'm going to combine like terms, so subtract 72. And then I have 72 on this side, 8y equals 72. And I'm going to divide both sides by 8. And so y equals 9. So I've gotten the same solution each time, that y equals 9, x equals 6. So again, that was my verifying right there. And so my solution is the coordinates 6, 9, my x and my y. And the meaning of my answer is I would say that 6 trumpets and 9 drums rent for $144. In problem 3, I'm going to solve the system of equations by graphing. And so if a line or an equation is not in slope-intercept form, I want to rewrite that in slope-intercept form. So starting with the first one, it is in slope-intercept form. So 2x plus 1, I know that the y-intercept is positive 1, and I have a slope of positive 2. So up 2 over 1, up 2 over 1. And I'm going to go ahead and graph that in here as best as I can. And then I have in my other equation, again, I need to rewrite this for y equals. So y equals negative 5 minus x, since I have to move the x to the other side. And so now I have a intercept of negative 5, and I have a slope of negative 1. So down 1 over 1, down 1 over 1. And so if I go ahead and graph these guys here, I can see my solution approximately here is negative 2 over negative 2, down negative 3. And that's the solution to that system of equations. All right, these were probably the most challenging problems for some people on this test, just remembering substitution and elimination, all those pieces. So starting with A, this might have been a straightforward place to use what we call the break-even method. So x plus 2 equals 11 minus 2x. I'm going to combine like terms. So I'm going to subtract 2, add 2x to the other side. So I end up with 3x equals 9. Divide by 3. I get that x equals 3. Again, I'm going to check that my solution works in both equations. So I want to find y. Y equals 11 minus 2 times 3. Y equals 11 minus 6. I'm thinking that y equals 5. But I'm going to try it in my other equation too. So y equals x, which I think is 3, plus 2. That again gives me that y equals 5. So my solution is the point 3, 5. For B, this is probably a good problem for substitution. So plugging this part in here for y. So 4x minus 3 times 4 minus x equals 16. So 4x, I need to distribute the negative 3 to both terms. So negative 3 times 4 is negative 12. Negative 3 times negative x is positive 3x equals 16. Again, I'm going to start combining like terms. So I'm going to add 12 over here. 4x and 3x makes 7x. So 7x equals 28. Divide by 7 on each side. X equals 4. And now I'm going to plug in both equations. So 4 times 4 minus 3y equals 16. 16 minus 3y equals 16. If I subtract 16 from each side, I get negative 3y equals 0. So that tells me, again, if I think about it, something times negative 3 makes 0. This is going to have to be y equals 0. Again, I'm going to check my other equation as well. So the second equation says y equals 4 minus x, and I think x is 4, so y equals 4 minus 4. 4 minus 4 is 0. So my point is 4, 0. The last one here is an elimination problem. If you used a different method, that can work too, but elimination is probably your best strategy. So looking at this, I might notice, for example, the 5y and the 10y and think maybe I would like to eliminate that piece. So I might multiply this entire equation by negative 2. So negative 3x plus 10y equals 2. That equation stays the same. The other equation becomes positive 4x minus 10y equals negative 6. Notice we've distributed the negative 2 to every single term. So now I'm going to just add these equations together. Negative 3x plus 4x makes x. 10y minus 10y is just eliminated, and then equals 2. All right, going back to that for just a second. So x equals 2 plus negative 6 is negative 4. So I'm thinking that x is going to equal negative 4. So now I have to check in both of my equations. So negative 3 times negative 4 plus 10y equals 2. I have 12 plus 10y equals 2. I'm going to subtract 12 from each side to combine my like terms. So I have 10y equals negative 10. I'm going to divide by 10, and I get that y is negative 1. So now I'm going to check my other equation. So negative 2 times negative 4 plus 5 times y equals 3. Again, I have positive 8 plus 5y equals 3. Combining like terms, I have 5y equals negative 5. Dividing by 5, I get that y equals negative 1 also. Again, it's really important to check your answer in both equations. So my solution here, my x comes first, negative 4, negative 1. Now we're going to translate these phrases into symbols. And so when you see a number, we're going to treat that as x. You could have used a different variable though as well. So when numbers decrease by 7, x minus 7, that makes a quantity, and that result is more than negative 2. So that is going to be greater than negative 2. For B, 10 more, so 10 plus 12 times the number, 12x, is at most 50. So it could be equal to 50. But it could also be less than 50 because it can't be bigger than that. So it should be less than or equal to 50. And C, the sum of a number, or sorry, sum of 8, so 8 plus a number multiplied by 7, 7x, is at least 36. So again, it could be greater than or equal to 36. Now for 6, we're going to write some inequalities. So I need to find these values. So for example, I can tell this is -9. So this means x is less than -9. It's an open circle. And the other one here, I have -2. X is greater than or equal to -2. Those are two different statements that I'm going to write to describe that inequality. And then for B, I see that this value is -10 and this value is -6. So I can say that x is greater than -10 but less than -6. For number 7, we're going to solve this inequality. So I have 5 minus 2x is greater than or equal to -3. So I'm going to go ahead and combine like terms. Subtract 5, subtract 5. I have -2x is greater than or equal to -8. I'm going to divide by -2. And when I divide by that negative, I must flip the inequality. So I have x is less than or equal to 4. And so the next part asked me which one is not a solution. So which number is not less than or equal to 4? That would be D, 5. For questions 8 through 10, I need to solve and graph the solutions. So to start off, I'm going to combine like terms. So I'm going to subtract, or actually I'm going to go the other way. I'm going to keep x on this side. So I'm going to subtract 700 from each side. I'm also going to add 59x to each side. So that leaves me with 60x greater than or equal to, and this is 130 minus 700. And so I have to be really careful here in thinking about my signs. This is -570. And so I am dividing now by 60 on each side. So x is greater than or equal to -9.5. So on my graph here, I'm going to note where -9.5 is. I'm going to make this a closed dot because of the greater than or equal to, and I'm going to be going greater than, so I'm going to be going to the right, should be pointing to the right. For number 9, this is a two-part. Notice it has the word or. So I'm going to solve each one for x and then graph those inequalities. So here I'm going to combine like terms, plus 5 and plus 5. I have -5x is greater than 50. However, when I divide by -5, I have to flip my inequality. So x is less than -10. So I'm going to note where -10 is. X is less than -10. So this is an open circle going to the left. And then the second part of my inequality, I'm going to add 11 to each side. So I have -6x is less than or equal to 30. Divide by -6. I'm going to flip my inequality again. X is greater than or equal to -5. So I'm going to mark in -5. Now it's greater than or equal to, so this is a closed dot, and it is pointing to the right. And finally for number 10, this is a three-part inequality. So in order to get x by itself, I'm going to add 12 to each term. So I have -5 is less than or equal to x is less than -1. So I'm going to note where -5 is, note where -1 is. And I know that x is greater than, actually, greater than or equal to -5. Okay, so this is going to be a closed dot. And then the other one, x is less than -1. So this is an open dot. And I'm simply creating the line segment in between them. For problem 11, we're going to be solving this inequality by graphing. So it's already in slope-intercept form. So I'm going to note where my -3 y-intercept is, and my slope is +2. So up 2 over 1, up 2 over 1. And again, I'm going to draw that line, which is going to be approximate here. And the values are greater than or equal to. So this is going to be a solid line, and I'm going to be shading above the line since it's greater than or equal to. For number 12, I need to rewrite this in slope-intercept form. So 3x minus 6y is greater than 18. I'm going to subtract 3x from each side. So I have -6y is greater than 18 minus 3x. I know it's a little bit hard to see. My last step is to divide all the terms by -6. So I get y, and I'm dividing by a negative, so I have to flip the inequality, is less than -3 plus a half x, or 0.5x. All right, so graphing this, the y-intercept is -3. My slope is 1/2, so up 1 over 2, up 1 over 2. So this is approximately my line, and it's less than, so I'm shading below. The other piece to notice here, though, is this symbol causes it to be a dashed line. So you will need to go back and make sure that this is a dashed line and not a solid line. So I need to put these equations into slope-intercept form to solve them and to graph them. So to start off, I have 2x minus 5y is less than or equal to 10. So setting that up, I want to isolate y. So I'm going to subtract 2x from each side. So I have -5y is less than or equal to 10 minus 2x. I'm going to divide both or all pieces by -5. So y, and I must flip my inequality because I'm dividing by a negative, is greater than or equal to -2 plus 2/5 x. So I'm going to graph that. I have -2 as my y-intercept. The slope is 2/5, so over 2, up 2 over 5, up 2 over 5. I'm going to go ahead and graph that line. My solution is greater than or equal to. So this should be a solid line, and I'm going to be shading up above it. And now I'm going to go ahead and find the other. So 2x plus 5y is greater than 10. I'm going to subtract 2x from each side. 5y is greater than 10 minus 2x. Divide each piece by 5. Y is greater than 2 minus 2/5 x. So now I'm going to graph my y-intercept for the second line at +2. My slope is -2/5, so down 2 over 5. So this line is going to be looking kind of like this. And again, I'm going for greater than. This needs to be a dashed line, which is kind of hard to do here. I can't really erase part of it. So make sure this is dashed, and I'm shading up above. So my solution is where they cross, and so I can see actually that's all of this part right here. This should be my solution to this system of inequalities. And for 14, I have y is greater than or equal to 1. So I'm looking for where y is, and I look for 1 here. I'm going to have a solid line right here at +1, and it's greater than, so this is shading up above. And then for my second, I have this equation here in point slope form. So it's probably helpful to turn this into y-intercept form. So y is less than or equal to 4 plus 2/3 x. I'm distributing the 2/3, and 2/3 times -1, so minus 2/3. So now I can combine similar terms. So 4 minus 2/3 is going to give me 3 1/3 plus 2/3 x. So go ahead and find your y-intercept at 3 1/3 approximately, and you're going to graph your slope of 2/3. So up 2 over 3, up 2 over 3. So it's going to be approximately like this. And we are graphing below, so less than or equal to. So this is a solid line. We're shading below, so we should have this region here as our solution.